We're going to learn what like surds are, and then we're going to apply that to addition and subtraction of surds. So first task, simplify this without the use of a calculator. And simplify would mean it's an exact answer, no decimals. And we're not going to use a calculator, we're going to do it by hand. So 5 root 2 minus root 8. What we do is we need to look at root 2 because it can't be simplified. And root 2, as you know, is a surd and it can't be reduced down or simplified from there. Root 8, if you've worked with that before, you know it can be simplified because from our previous works, square root of 8 can be expressed as the product of two of its factors, and it's important that one of those factors is a square number, and 4 is a square factor. So we can split that like so. We've seen this in our previous work. Square root of 4 is 2, and root 2, as we said just over here, is can't be simplified beyond that. That's its exact value. So it's 2 times root 2. We write that as 2 root 2. So when we come back over to the question here, we've got 5 root 2 minus 2 root 2. Whoops, 2 root 2, not root. Now, if you can remember back to some of the algebra you've done before, this is a thinking step. You wouldn't write this, but if you had 5 instead of root 2, let's say x, if you had 5x minus 2 lots of x, that's easy, isn't it? That's 3x because they're like terms. Surds can be grouped in the same sort of way. So we have like terms in algebra, we have like surds with this work on irrational numbers. So we have 5 groups of something minus 2 groups of something is 3 groups of that thing. So the answer is 3 root 2. So that is simplified, and we know that because that is an integer value, and that is, as we know, in its simplest and most exact form. So that's finished. So the answer to that is 3 root 2. This is the second example out of 3 examples. So we have to simplify 2 root 5 minus 3 root 20 plus 6 root 45. And again, we're looking for like surds. We won't always find them, but we find as many like surds as we can. We're going on a journey and a search for like surds, so we look for them wherever we can. So we need to be thinking as we're doing this. So looking at the first term, 2 root 5, we should know by now that that cannot be reduced down any further because root 5 is a surd and it cannot be reduced down into any factors where 1's a square. 5's prime number too, which helps us decide that. So we write 2 root 5 down again. Okay. Now the second term says 3 root 20. So it's 3 times root 20. Now root 20, can it be broken down? Indeed it can. What's the largest square factor? 4. 4 times 5. The third term, 6 root 45 is 6 lots of the square root of 45. Can 45 be broken down into square factors? Yes. And what's the biggest one? 9. 9 by 5 is 45. Okay, good. We're getting somewhere. 2 root 5 minus 3. Now we split that surd into 2 individual surds like that, plus 6 root 9 by root 5. And then we look at ways of simplifying that. Now have a look. We've got square root of 4. We've got square root of 9. And by the way, if you can't see it, there's time signs there. If you can see where my cursor is, and there. Okay, but we don't have to write them, just like with algebra. So 2 root 5. Now the yellow circles, I'm going to simplify the terms inside them. 3 times square root of 4 is 2, times root 5, plus 6 times square root of 9 is 3, times square root of 5. Now have a look at what's emerging here. This is a good situation when this happens. If you have a look in the purple, root 5, root 5, root 5, like surds are coming up there. The more the better. So, continuing on, we have 2 root 5. Now because we got times signs there, we can multiply them in any order. It makes sense to go 3 times 2. 6 times root 5, which is just 6 root 5. And then 6 by 3 is 18, plus 18 times root 5, or 18 root 5. Last step, we have everything in like terms. So imagine if we had 2x minus 6x plus 18x. We could easily simplify that. So 2 takes 6 is negative 4. Negative 4 plus 18 is 14x. So what we really have then with like surds is 14 root 5. Quick check, is that simplified? 14 is 14, it's an integer. Root 5, as we said previously, is an exact value. It's a surd, it cannot be reduced. It cannot be written in a decimal form in a precise way, so yes, 14 root 5. Simplifying the last one now, whenever we have fractions, like with algebra or just regular numbers or surds, we need to find a common denominator when we're subtracting fractions. Now, again, don't be afraid of this, because if you saw by now at this stage, if you saw 3x over 10 minus 8x over 10, by now you'd have no trouble, because you'd know that that's 3x minus 8x over a common denominator. Even if the denominator wasn't common, what would we have to do? It'd be an easy adjustment. We'd find the lowest common multiple of 10 and 15, and that'd be 30. So the first term, top and bottom, need to be multiplied by 3. Second term, the numerator and denominator need to be multiplied by 2. And you'd have 9x minus 16x over a common denominator, 30. And then we have negative 7x on 30. So if we translate that idea to the question we're doing, we can just apply the same process. We want a common denominator, and basically we go for 30ths, just like we saw there in orange. It's exceptionally important to be good at your operations with fractions. Okay, if you're going to do any sort of maths beyond a basic level, you need to be very good and fluent with your fraction operations and processes like this. So to go from 10 to 30, we've multiplied the denominator by 3. We must multiply the numerator by 3. 3 root 3 times 3 is 9 root 3. Second term, 15 goes to 30 multiplied by 2, so we must multiply the top, the numerator, by 2. 8 times 2 is 16, lots of root 3. And again, 9 take 16 is negative 7 lots of root 3 over 30. Voila!